Welcome back. We're going to start on our next unit. This is involves trigonometry, chapter 13. So let the trig begin today. Our target for today will be that I can use right angle trigonometry to find the value of all trig functions at a given angle. This will be should be a lot of review from your geometry, trigonometry lessons. So hopefully that's the case. If not, we'll refresh your memory as we go. Have this written down or have this written down for the rest of your notes, and so I can see it tomorrow in class. Okay, trigonometry, or trig, as we call it for short. Literally, trigonometry is triangle measuring. So it's the study of triangles. In the branch of mathematics, it deals with the relationships between the sides and angles of triangles, and the calculations based on them. One focus is on right triangles, where one angle is 90 degrees. Branch of mathematics, it deals with trigonometric functions such as sine, cosine, and tangent. These are all different definitions you can find in different places online or in different books. That's what trigonometry is. Basically, if you see the theme, it's triangles, and specifically right triangle trigonometry. That's what we're going to focus most of our time on in this class. Okay, so here are some things that you covered in geometry. One was the two special right triangles. One was a 45-45 90-degree triangle, and the other was a 30-60 90-degree triangle. And these sides have the same ratios, no matter where you draw them or how big, how small. If you have a 45-45 90 triangle, then the ratios are always the same. 1 by 1 by square root of 2. The hypotenuse is square root of 2. The legs are 1. And that makes sense if you use the Pythagorean theorem, which we're going to get to in a minute. That works out mathematically. 30-60 90, if we let the side across from 30 be 1, hypotenuse is then 2, and this other leg is the square root of 3. So these triangles will have this type of relationship, and it lets us solve for different angles as well. So it lets us find the ratios of sine, cosine, and tangent rather easily if we know these special triangle relationships. Another thing that we didn't learn in geometry is the sum of the interior angles of the triangle is 180 degrees. So in the right triangle, the other two angles must add up to 90. The Pythagorean theorem applies to right triangles. We talked about that before. A squared plus b squared equals c squared. Remember, c squared, that's the hypotenuse, so c is the hypotenuse. So A, B, C. And similar triangles are triangles with equal angles, or corresponding angles are equal, but the sides are just proportional. They're not exactly the same. The congruency, that means they're the same size and shape, but when they're similar, they're just the ratio of sides are the same all the way around. Okay? So if side S is little s is proportional to big S, and little h is proportional to big H, and big T is proportional to little t, then that means that big S divided by little s equals big H divided by little h, or big T divided by little t. So that's what we mean by corresponding, or corresponding sides being proportional. This little chart you might find useful for your notes. I have it on my note sheet in class, but you might find it useful for your own use at home, or when you don't have the note sheet in front of you. This shows a 30-60-90, just like I drew it, or similar to how I drew it on the last slide, and same with the 45-45-90. And this lets us find the trig ratios. When we define them, you'll see how this makes sense here in 1 minute. But then using this drawing is going to help us to see that the sine of 30 degrees is 1/2 based on the definition. Okay, but there's all this chart, you don't have to memorize it. As long as you can memorize the 30-60-90 and the 45-45-90 where the ratios are on there, the side lengths, you'll be able to find sine, cosine, tangent, cosecant, secant, and cotangent very easily. So copy this down for your notes. So hopefully you copied that previous slide, all that information down. Let's go through our definitions of sine, cosine, tangent, cosecant, secant, and cotangent. Okay? SOHCAHTOA, if you remember that little mnemonic device from geometry, SOHCAHTOA can help us memorize the ratios. S, it stands for sine, opposite over hypotenuse. So this is sine, which is op over hypotenuse. Ca, C-A-H, that's cosine adjacent divided by hypotenuse. And toa, that's tangent. Okay, and that's opposite divided by adjacent. Okay, so that's going to help us find all the trig values. So opposite over adjacent. So if I'm standing here at this angle, this theta, the 0 with a line through it, that's theta, it's a Greek letter. Then the sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, the opposites in the adjacent parts will change depending upon which corner you're standing on. So we're not usually going to stand in the right angle corner. It's going to be the two non-right angles that we use. So if we move theta up to this corner, well then our opposite and our adjacent sides, they would have to switch sides as well. Switch places. And we're not going to we won't do that right now, but then just keep that in mind. Hypotenuse is the only one that stays in the same spot every single time. Opposite and adjacent, that depends on where your angle is. Okay? Cosecant, secant, and cotangent, they're the reciprocal functions for sine, cosine, and cotangent respectively. Cosecant is just sine flipped. So it's hypotenuse over opposite, or 1 over sine. Secant is cosine flipped, so it's hypotenuse over adjacent, or 1 over cosine. And cotangent is adjacent over opposite, or 1 over tangent. Okay, so why is this important? Well, trig functions, or the trig functions sine, cosine, and tangent allow us to kind of solve for missing sides and possibly eventually even missing angles in a triangle. We're going to focus on sides today. And lets us find the ratios, which is going to be helpful down the road. So if we can use these definitions and practice them now, we may be able to use them, solve different types of problems later. So it says find the 6 trig functions for theta. Well, to find all 6 trig functions, I need to know all 3 side lengths. I only know 2. How am I going to find the hypotenuse? How am I going to find this side right over here? Well, I'm going to use the Pythagorean theorem. I'm going to do a squared plus b squared equals c squared. Our legs are 8 and 15. I know they are because they're not the side across from the 90-degree angle. So 8 squared plus 15 squared, well, that's going to be 289. We square root of both sides, we end up with c equals 17. And we don't do plus or minus here. Well, if you think about it, why don't we do plus or minus? The reason, we can't have negative lengths. I know normally we square root both sides of the equation, we get plus or minus 17, but we're dealing with the actual hypotenuse of the triangle. It cannot be negative. So, we have all 3 sides. Now we just have to find sine, cosine, and tangent. Cosecant, secant, and cosecant. Well, sine is equal to the opposite over the hypotenuse. If we're standing here at theta, I'm going to trace out here, we're standing in this corner, which side is opposite? Well, 8 is opposite. Which side is adjacent? 15 is adjacent. Hypotenuse is already established, it was across the 90-degree angle. Notice adjacent and hypotenuse are the only 2 sides that touch the angle, or make up the angle. The opposite does not make up a side of the angle. Okay? So some people will flip-flop hypotenuse and adjacent sometimes. They'll get those mixed up. Please don't let that be you. So the opposite side is 8, the hypotenuse is 17, so 8 over 17 is my sine for this one. cosine, that is adjacent over hypotenuse. Adjacent is 15, hypotenuse is still 17, so 15 17ths. Tangent, opposite over adjacent, which is 8 over 15. Now, secant, cosecant, that is just a flip of sine. So the fastest way to do that is to say, okay, if I know what sine is, flip it. I get 17 over 18. Secant is hypotenuse over adjacent, or 17 over 15. It's the reciprocal of cosine. And tangent, that's going to be 15 over 8. There are the 6 trig functions for this triangle. Trig ratios also let us solve for sides, like I said. I'll use an opportunity to do that. So use a calculator to find the values of x and y. Well, I could use the Pythagorean theorem to find them if I knew 2 of the 3 sides. If I only know one side and one angle, I can set up a trig function to help me find the missing side. So if I'm now hitting 56 degrees, I'm standing at 56 degrees, 13 then is my adjacent side, x is my opposite side, and y is the hypotenuse. So if I want to find, let's say, x, opposite and adjacent, what trig function uses opposite of and adjacent? The tangent does. So I can set up the equation, the tangent of 56 degrees equals x over 13. And I can use my calculator to solve this. I isolate x by multiplying both sides by 13. And so in my calculator, a couple things have to happen here. One, I have to make sure my mode is in degree. Quite often, your mode will be in radians when you first start doing this. You switch it over to degrees. I hit mode, and I went down to degree, and I hit enter on degree, so now degree is highlighted. Secondly, I'm just going to put in the numbers. 13 times tangent. Tangent's that button right next to the power key, TAN. Some cosine and sine there too. Tangent of 56 degrees. So 13 times the tangent of 56 degrees, I get 19.27. So my x is 19.3. Okay? Now, I have 2 sides. Could I use the Pythagorean theorem? I could. So I could do 13 squared plus 19.3 squared equals y squared, and we have our hypotenuse. I'm going to practice doing another trig ratio because I know we've done the hypotenuse method before. So let's say we want to do the adjacent and the hypotenuse this time. What trig function does adjacent and hypotenuse? Well, cosine does. Cosine of 56 equals 13 over y. I like to use sine, cosine, and tangent because those are the buttons on our calculator. First of all, we want to get y by itself, but we can't have y be in the denominator. So we're going to multiply y on both sides. Normally we don't do that, but I can't solve for y when it's in the denominator, in a fraction. So I've got to get it out of the denominator. So y times the cosine of 56 equals 13. Cosine of 56 is just a number. When I put it in the calculator, it just gives me a number. I can multiply and divide that on both sides just like any other number. And so y equals 13 over cosine of 56. What happened here? If we notice our original equation, basically the y and the cosine of 56 flip-flop. That's kind of the shortcut for it. I want to show you mathematically why that worked out. Okay, but basically, these are going to flip places when we're solving. So in our calculator, we can hit alpha y equals 13 over the cosine of 56. And we get 23.24 or 23.25. So those are our 2 answers. Now if we want to test this out, Pythagorean theorem with 19.3 and 23.25, we do the Pythagorean theorem with 13, it should come out to be pretty close. 13 squared plus 19.3 squared should be pretty close to 23.25 squared. Won't be exactly rounded, but it should be very, very close. Okay, last type of thing we're going to ask you for, or I'm going to ask you for, is to solve a triangle. Solving a triangle means you find all the missing angles and all the missing sides. We're given angle A, we're given angle C, we're also given side C. So, angle A is 37 degrees. Angle B, we don't know. Angle C is 90 degrees. Side A is, we don't know. Side B, we don't know. Side C is 22. We need to find these missing sides and the missing angle. The missing angle, that should be the easiest one to find. What do the two non-90 degree angles add up to? So the two non-90 degrees have to add up to 80. Okay, the two smaller angles, two acute angles have to add up to 80. So 90 degrees will equal 37 degrees plus angle B. We solved that one for angle B. 90 minus 37 is 53 degrees. So angle B is 53 degrees. So everybody, when I say solve an angle on a quiz or a test, we should have no problem at least identifying the missing angle. The missing sides, that's going to be using your trig functions like we did on the previous problems. So I know that side C is 22. If I'm using angle A, 37 degrees. If I want to find A, side A, that's an opposite and a hypotenuse. Which one does opposite and hypotenuse? That'd be sine, right? So the sine of 37 equals A over 22. Now, some of you saying, well, couldn't I have done cosine of 53 and gotten the same ratio? Yes, you could have. Very critical or important observation. I multiply both sides by 22, and then I put it in my calculator. 22 times the sine of sine of 37. Remember, we already changed our calculator to degrees, so we still should be good. We don't have to do it every time. 13.23. So 13.23 or 13.2 is A. So we're going to fill it in our chart here as well. And we know A is 13.2 here. Now I have options. I can use Pythagorean theorem to find B. I can use another trig ratio if I want. This time, maybe we'll do cosine of 37. The cosine of 37, well, that's adjacent and hypotenuse. That'd be B over 22. Multiply both sides by 22. We get 22 times the cosine of 37 equals B. When we plug that in our calculator, we should get 17.6. Okay. So there's our solved triangle. Put a box around it so I can find all your missing pieces. And then work with the opposite side. Okay, last one we have to look at today. We have lots of examples today. If I just give you a sign, like give you one trig ratios, and it says find the values of the 5 other trigonometric functions. Well, basically by just giving the sine of theta equals 4 over 7, what I'm doing to you is I'm kind of describing a triangle. Sine, remember, is opposite over hypotenuse. If this is my angle theta, this is opposite, this is hypotenuse. So I'm giving you 4 and 7. We're missing the adjacent side. Okay? So the 5 other trig function values, well, remember the trig functions are sine, cosine, tangent, and then we have cosecant, we have secant, we have cotangent. Well, if sine is already 4/7, if we're given that, then cosecant, because it's reciprocal, has to be 7 over 4. So there's one. How are we going to find the other 4 angles. These are the other 4 trig functions. Well, we need that missing side. We know 2 of the 3 sides, so we can use the Pythagorean theorem. 4 squared plus a squared equals 7 squared. Remember, 7 is a hypotenuse, so it has to go in for c. When we solve this, we get 16 plus a squared equals 49. Minus both sides by 16, we get a squared equals the square root of 30. Excuse me, a squared equals 33. To solve the equation for a, we square root both sides. I don't think the square root of 33 can be broken down by any perfect squares. So a equals the square root of 33. Now, if we know that, then we can find this cosine, tangent, secant, and cotangent. Cosine is adjacent over hypotenuse. That would be the square root of 33 over 7. Okay? And secant then would be 7 over the square root of 33. Now, the problem with this is you can't have square roots in the denominator. How do you get rid of square roots in the denominator? You multiply the top and you multiply the bottom by whatever that square root value is. So we end up getting 7 square roots of 33 over the square root of 33 squared. What is the square root of 33 squared going to be? It's just going to be 33. So secant of theta is 7 square roots of 33 over 33. Tangent. Tangent is defined as opposite over adjacent. That's 4 over the square root of 33. We're going to do the same thing we did in the last one. Multiply the top and multiply the bottom by the square root of 33. We end up with 4 square roots of 33 over the square root of 33 squared, which once again is just 33. Cotangent. 4 over the square root of 33, just flip it. That's the square root of 33 over 4. And we have just, by only knowing one trig ratio, we've now found the other 5. Okay, so I think we hit our target. We reviewed a lot of right triangle trig today. So make sure you have your notes down. I know they're a little longer today, but hopefully it wasn't so bad. And your notes, if you check tomorrow, we'll see you in class.